In this video, we'll discuss the area of polygons. Now, within polygons, there are several principles that can help us. For example, the additivity principle states that if we take a large shape that's hard to find the area, we can split into smaller shapes that have no overlaps, that are much easier to find, and the sum of those smaller shapes, their area will be equal to the area of the overall shape. For example, say that I have my basement and it's shaped something like this, and I need to lay down 1 square foot tiles. Well, this shape is not easy to find as it is, but what I can do is split it into 2 smaller shapes. For example, if I just draw this line here, I now have 2 rectangles, a 6 by 7 and a 15 by 18. I can take those 2 areas, sum them together to get the entire area of my basement. I could have also went horizontally and looked at the 6 by 22 space and the 15 by 12 space, and again I sum those 2 areas to get 312 square feet. Since each tile is 1 square foot, I know I would need 312 tiles. But this would not have been possible without recognizing how I can use the additivity principle to solve this problem. Another principle I can use is the moving principle, which states that I can take parts of a shape, move them without stretching them, and I can create the same area. And that's helpful when I get odd looking shapes that may fit together to form a better shape for finding area. For example, I recognize if I draw a line across here and I cut off this top piece and move it, I can place it in here like a puzzle piece and it forms a rectangle. The rectangle I can easily do 22 by 30 and get 660 square feet. Much easier to find. Now, there are several common formulas you should know. One of those is the triangle, which states that the area of a triangle is 1/2 the length of the base times the height. Now, the base length can be any side. It can be any of the sides. The height is based on which one is our base, and it's going to go the perpendicular distance to the opposite vertex. So say I have this triangle ABC. First, I need to recognize what do I want to make my base. I can make it any of the sides, but if I'm on a grid, it makes the most sense to choose the side that I can count blocks to help me with. So in this example, I would say AC is my easiest side to create as the base. It is 4 centimeters because there's 4 blocks. Now I need to figure out, well, where's the perpendicular height? So I need to go over to point B perpendicularly. So if I think about this problem, I need to create a dotted line out here to create that perpendicular height, which in this case will be from D to B. And I measure that, that's 3 blocks or 3 centimeters. Find the area of this triangle, 1/2 of 4 times 3 will give me 6 square centimeters. Now I can think about recreating triangles on grid paper in the same way using the principles. Why does what I just did work? Well, if I think about the fact here is we'll keep things simple with a right triangle. If I draw, since this is 4 blocks, and go halfway across and make this triangle, I can rotate it and it will fit perfectly here and giving me the area, which is 2 by 3. Now I could have used the additivity principle as well and recognized, well, if I make an entire rectangle, instead of adding, I subtract out the space that's not left, which would be half of this rectangle. I could say that this is a 4 by 3 and I'm removing half of it, so half of a 4 by 3 would give me 6. Same triangle using the different principles beyond just this typical formula we know for the area of a triangle. Another common formula you should know is the area of a parallelogram. Now with this, we also recognize that this could be used for a square and a rectangle as well. Any of the 4 sides can be the base, just like in a triangle, and we're going to create the height being perpendicular from one base to the opposite base. So in this case, I would use either side AD or side BC since I can count using the blocks. In this case, I'll use side BC. BC, if I measure, would be 5 units or 5 centimeters. Now I need to create the perpendicular height to the opposite side. Just like the other problem, I want to create that perpendicular segment, so I would draw in segment AE and measure it to recognize that it is 3 centimeters. So now area base times height will be 5 times 3, which is 15 square centimeters. Now why does this work? Think back to our additivity principle. I could take and draw in 2 lines and create two triangles, and a rectangle. The area of each of those is very simple to find. 1/2 of a 2 by 4, and then the rectangle is 2 by 4, and then the third area is 1/2 of a 2 by 4. I sum all three of those areas together and I get 16. If I use the moving principle, I could draw in a line, could take this right-hand triangle and move it to the other side, and I see that I form a rectangle. Specifically in this case, this rectangle is a square. It's 4 by 4. So 4 by 4 is 16. Final shape that you should know in this case is going to be the area of a trapezoid. The area of a trapezoid takes 1/2 of the quantity of the two bases added together times the height. So the bases are going to be our parallel sides of the trapezoid. That's an important thing to recognize. And the height is the perpendicular distance between those two bases. So here's an example. First, I want to recognize what are my bases. So it'd be AB, which in this case is 2 units. DC, if I counted, would be 8 units. And to find the perpendicular height, I can draw that in, and I recognize that it again is 2 units. So if I put each of the parts into my formula, I would have 1/2 of the quantity 2 plus 8 times 2. So 10 times 2 is 20. 20 divided by 2 is 10. Now how can I use the principles to help with this one? Well, I could, just like the parallelogram, first recognize what is my area of the trapezoid. So I've got 7 for my segment DC and 4 for my segment AB, and then my height is 4 units. So that's going to give me 22. So if I use the additivity principle like I did for the parallelogram, I could draw in the distance on the right hand side and realize I have 3 shapes again. Find the area of each of those 3 shapes and then sum them together and I'd get 22. So there's other ways beyond just knowing these formulas. I can always find the area of any of my shapes, including the common ones that I work with the most.